All right, today we're going to be doing the speed of light experiment using the apparatus we purchased recently. And here is the setup. We have an oscilloscope, which will keep track of the measurements. We have the device itself, which consists of a laser that goes into a beam splitter, which means that it divides the beam into one direction reflected sideways, the other direction going straight. And what we then, as we can see here, and then here's the reflector. And what we'll do is we'll be measuring the distance between the laser box and the reflector. And we'll be doing this for measurements of 1 meter, 3 meters, and 5 meters away from the system. All right, here's the apparatus. So this is what we'll be looking at. And then giving you a little more introduction to this, the way the speed of light is. This was first measured a long time ago. We're not going to get into details there. So we have as the example here is we have the laser device. We have receiver, which then goes into the oscilloscope, channel 2 in this case. And then what we're going to see is a peak on the oscilloscope, and we adjust the intensity so that we can have a nice clear peak. And what we're going to be looking for is the time where the peak circled in red, half the peak intensity, and we'll be measuring that. And then what we'll be doing is starting from 0, having again the reflector right next to the system itself, as we show here. So that'll be 0, that'll be our baseline. Then we'll move the reflector out, and we'll get another point, as we can see here. And the time difference will be the difference between the half peak of the reference line and for 1 meter and so on. And what it'll turn out to be is distance L, which again we have is 135. The distance there and back will be S. And then based on that, we can determine the velocity, and we'll get into those details a little bit later. And then we'll need to make a correction for the lab using the index refraction for air of 1.000288. All right, here's the oscilloscope reading for the placement of the reflector right at 0. We have a peak here. Goes here. We're actually interested in this point right here, which crosses the y-axis. And what we're going to be doing is this pulse makes 30 times a second, but as you can see, if we take just no average, so if you just have the sample, all right, we get a wildly crazy number because the peaks are not, the pulses are not exactly the same each time. So what we do is we average that over 120 number of peaks. We start with 4. We get a little bit of a shift. We do 8 or 16, I should say. We get a little bit better. 64, and the maximum we can do is 128. So again, what we're going to be looking for will be the time for where it crosses this x-axis on this x line. And each of these major lines, as you can see, are in 5 nanoseconds. So each little line is 1 nanosecond. So I'll let you measure that, figure that out. But my estimation, if this is 0 here, then this would be approximately, in my opinion, about 4.2 nanoseconds. So that's what we're interested in there. And that'll be our baseline. And what I'll be doing is taking pictures of each of the different marks, and you can make the measurements from there.